equals 17. Is that right? 17. So we've got 8 I1, 13 I3, but there's no I2s in there, right? And now you know where we're headed, yes? We set up a matrix, right? And it's going to be 1, 8, 8, -1, 18, 0, -1, 0, 13, I1, I2, I3. So these guys go like this. Remember that matrix goes zoop, zoop, zoop. I hope that sounds good on the wireless mic. Okay, and then that equals the answer matrix, which is 0, 17, 17. Yeah? And then this is going to be A, and this is going to be B, and then I think, well, how do we do the answer? I think we go A inverse B, is that right? Isn't the answer A inverse? Equals I1, I2, I3. Yeah, but we don't need to do that, right? Okay, so Excel, you can set up matrices in Excel, so let's just type it in here. And let's see if we've got the right matrix first before we type it into our TI calculators, which is somewhat more difficult. 8, whoops, 89, 8, and -1, and 18 and 0. Okay. And then -1, 0, 13. Yeah? And then this one is 0. There we go. We're getting answers, so now the question is, do we have the right answers? So let's just check. A3 should be, the value for A3 should be I1. So 1.09336, A3 is 1.093. So that's hopeful, right? Okay, so we got that current. A2 should be I2. A2 is 0.459, 0.459. Yeah? I think we got the right answer, right? A1 should be I3. A1 is 0.635 on here. It's 0.63485. So it looks like we got it right. Yeah? Isn't that cool? Now, do we remember how to put it in our calculators, our TIs? Yeah, so get out your TI. And let's have a little calculate-a-thon. All right. Okay, so how do we do this? We've got to go matrix, right? Second matrix. And I think what we want to do is go edit, right? Is that right? And then go enter. And then it's going to ask you what the dimensions are. And of course, we're going to make it a 3 by 3 matrix. And is this the same one? It's not quite the same one. Okay? But it looks very similar, doesn't it? So to change the things, we would type that in now. I happen to have it as a 3 by 3 matrix, but if you don't, go 3, forward, forward, 3, right? Okay? And then my matrix is a 1 here, and a -1, and a -1. Whoops. Go to. Oh, the wrong negative. Yeah, okay. You got to use unary minus, right? And then this guy is a -1. This guy is an 8, which is good. This guy is 18. And that guy's a 0, so this is good. I must have been solving another circuit problem. This guy's 8, 0, and 13. And then before I get out of here, I'm going to double check that that's the same as the matrix that we've got. And that looks good, doesn't it? Okay. And then I'm going to go, because I don't know how else to do it, I'm going to go second matrix, right? And I'm going to go down to B, and whoops, I got to go edit, and then down to B. right? So B is my answer matrix, and it should be a 3 by 1. And if it's not a 3 by 1, make it a 3 by 1. 3 by 1, right? And then 0. Zero is what I want there. And then I want these guys to be 17. And 17. Right? And then I'm done, aren't I? How do I get out of this? Just clear? Second mode. Quit. There we go. Okay. And now we need to barf them back up. So I go second matrix. And names is what I want. And A is the one I want to do. Right? And then I do x to the minus 1, which, if this is a data-driven operator there. If it's a number, it just goes 1 over the number. But if it's a matrix, then it inverts the matrix. Okay, that's kind of cool, right? It's a totally different operation, and some programming languages have this. So we applaud for TI for doing this, right? And then I need to barf up B, right? So I go down here, and I barf B up. And then if I hit enter, I should get the answer matrix, which is exactly what we got with Excel. So the syntax for setting up Excel to do this is fairly obscure. You actually have to name a region in the spreadsheet as something, and then it can become a matrix. And I have to look it up every time. So I just make a spreadsheet that has these matrices built in. Here's a 3 by 3, a 4 by 4, a 5 by 5, et cetera, et cetera. And you could make a 97 by 97, and it would be just as easy as a 3 by 3. And it's much easier to type in Excel. But the beauty of this is that we don't have to set it up in advance. It's not as hard to set up. So that's kind of cool. Isn't that cool? Yeah? I don't know. How many people like that way? It's kind of slick, isn't it?
It works for like simpler ones, but when you have more complicated circuits,
Andrew was like the last one done, but he did it with matrices. Like so the skill set one.
For this one, I think it'd be faster. But if you had like one of the huge circuits.
Yeah, for 3B, for 3B, I think I gave up. And then the problem I ran into is that you get so many zeros that sometimes the matrix is indeterminate. And I don't get that. So if it's indeterminate, what does that mean? Like there's zeros across it diagonally or something? What is it? I don't, I need to go back and learn about matrices or something. But there's something there, and I didn't know what it was, and so I'd get indeterminate ones. But I think you can rearrange these guys, can't you? Is that right? So sometimes you couldn't solve it, but if you put them just listed them in a different order, maybe they would be solvable. I don't know. I don't know the answer to that. So anyway.